So this paper is about common ownership in America, 1980 to 2017. So many of you have probably heard something about the common ownership hypothesis. It's been in the news quite a fair bit, but just to make sure we're all clear on the idea, economics usually starts with the premise that firms maximize profits. It's a very basic underlying assumption to most of what we do. It's kind of very natural that they would do this. You would want to do this if you were a private firm. If you're a public firm, you also want to do this because maximizing profits will maximize the share price as that reflects discounted future profits. But another way to think about this is that you really do answer to your investors, and that's what we teach our MBAs at business schools, right? The management is responsible to your investors, and well, what do your investors want? Well, it might be the case that some large investors may hold stakes in you and your competition. We call those common owners. So for example, if I have a big stake in Uber and a big stake in Lyft, well, I don't want them spending a lot of money poaching drivers from each other or poaching riders from each other. Okay, so the idea here is a common owner may not actually want you to solely profit maximize. They may want you something more like industry profit maximize. And so this paradigm says, well, maybe actually what firms do is they maximize the shareholder portfolio value. So it's a one little tweak in assumption, and as you'll see, you get a lot out of this one little tweak, okay? And now, this has been in the news a lot lately with sensationalist headlines as well. Things like, are index funds evil, or stealth socialism? Okay, so it's been kind of, the idea there is that because we're all putting our our retirement funds in these big index funds like we've been told to, that we're creating a problem, right? Because we're all indexing, we're buying the market, we're creating this common ownership idea, and it may be resulting in less competition. I want to focus on this last quote here from Reuters. When BlackRock calls, CEOs listen and do deals. BlackRock is, of course, one of the largest asset management firms in the world. And people often question around this common ownership hypothesis. They say, well, how would these investment management firms actually communicate with their desires with management? And well, just ask them what they do. That there's no CEO that doesn't return our call because typically we're high up on the shareholder register. At the very bottom it says, we are everybody's largest shareholder. Okay, so this is the common ownership hypothesis in a nutshell, and it's a concern. We have been thinking about this problem for a few years now, and we've kind of developed a mini agenda around studying this common ownership hypothesis. The first output of it was a Brookings Institute working paper where we basically do a lit review of the existing evidence, because there has been some empirical evidence purporting to find effects of common ownership on prices. The main point of that paper is to basically show all the data issues that exist, survey what methods are currently being used, and to basically point out why industrial organization economists are so-called cranky about the existing empirical evidence. Okay, IO is sometimes known as cranky about a lot of things, but in particular in this context, IO has had a lot of problems with the existing evidence. Most of today I'm going to spend talking about kind of a macro level view of what do these common ownership incentives look like in the economy. And so we're going to look at the S&P 500 over the past almost 40 years and try and figure this out. And what's nice is we're going to look at this very differently from the existing literature. And then we're going to just focus on the firm's incentives. Okay, so just write down the firm's objective function and figure out where the common ownership incentives show up. Okay, we're going to then decompose some long-term trends in this and show you what's been going on. And then I'm just going to kind of advertise that we're still working on a formal testing procedure to actually go to the data in differentiated product markets and actually assess whether it looks like there's evidence of common ownership affecting prices. I will not have time to get to that today, but I want to advertise, look for it in the next few months. We should have that working paper out. All right, so just a quick preview of what we're going to find. We do think this theory is, it's a self-consistent theory. It actually kind of makes sense in some ways. There's a bit of some questions around corporate governance, though, and we'll discuss those in this talk. One thing we want to emphasize, don't regress equilibrium object like price on other equilibrium objects such as MHHI. That's a bad idea, and I'll show you exactly why that's a bad idea in a couple slides. We instead study what we call the profit weights that are implied by common ownership. We're going to develop that in a few slides. In terms of the facts I'm going to show you from this paper, it's no surprise that institutional ownership is growing overall, like we know that. But we're going to show you that the implied profit weights that we compute for companies in the S&P 500 have been increasing greatly over time. Okay, and from 0.2 to 0.7, you'll understand it in a few slides what that means. What is happening here? A lot of those sensationalist articles have tried to blame Vanguard or BlackRock or State Street and said they're the problem, that's what's going on. But as we show, no, they're just the latest incarnation of a trend towards indexing. It used to be the case that you'd make a bet, right? You'd say, I think Eastern Airlines is really going to win, so I'm going to buy a big stake in Eastern Airlines. And today we know Warren Buffett has large stakes in every airline, right? So it's this move towards diversification that's really going on. We then try and quantify the effects. We basically calibrate a model and say, well, let's turn this on. Let's assume everyone was being kind of competitive in their pricing and then flip a switch and have them wake up and decide to price, taking into account this idea of maximizing shareholder portfolios. And the answer is it's big. Markups would increase pretty significantly. I'll show you exactly how much, but more than double over the 40-year period. And then finally, we also show that if there's say a privately held firm, a maverick as we're calling it, if one firm's kind of not going along with the common ownership in some sense, that can actually do a ton to discipline this whole effect. Okay, and so the fact that more of the economic activity is going on in private companies over time might be a good sign that we need to worry less about this. Okay, let me dive right in. The theory actually goes back to the 80s and 90s, but really why this took off and why the newspaper started paying attention was a set of papers that purported to find price effects in airlines and banks, and so that's the second bullet point. And that has just unleashed a torrent of new work on this whole topic. So we've seen replies to those papers, replies to those replies. We've seen papers proposing remedies. We should rein in index funds, which that's quite an extreme idea. We've also seen papers start to think about, well, maybe it's not in price, maybe it's in investment decisions or R&D or something else. So it's been a very active area of research. So let me just go through, this is about the only equation slide, okay? So let me just walk through though, what is this model and what does it imply? So here's a little notation. Investor S in firm F has rights to profits beta FS. Think of that as what percent of the company do you own. So if you have 5% of the shares, you have a claim to 5% of profits. Therefore, your investor portfolio is worth the sum across all of your investments of that beta times that company's profits. Okay, so that's just your portfolio value. Here's the first problem with the theory. I have many investors and they have different portfolios. They might disagree on what I should do in a given situation. To be concrete, suppose investor A owns a lot of American, a little United, and investor B owns a little American, a lot of United. Well, if you're American, those two investors would disagree on what you should do. So we have to kind of resolve this in some way. And the way this is done is with a Pareto weight gamma on each investor. So I say, I care gamma about investor A's portfolio. Okay? We'll come back to that. But now that we have these ingredients, we can just directly write out what is this firm's objective function. What are they trying to maximize? So they're maximizing, again, just their investors' portfolio values. If you write it out, it's the sum across all of my shareholders of gamma, how much I care about them, times their portfolio's value. I'm just going to do some, that's not a very nice expression. Let's rearrange a little bit. I'm going to just pull out my own profit and divide by its coefficient to normalize. So if you go down a line, you see what I really want to do is I want to maximize my own profit, that's the pi f, plus some weird weighted average of other firms' profits. Okay, and that weird weighting thing in front, that's what we're going to call the profit weight, kappa. The reason being is if you go to the right side, it all of a sudden has a very nice interpretation. I maximize my own profits plus the kappa weighted sum of other firms' profits. What's great about this is it prices other firms' profits, right? So this is my objective function. This tells me that if kappa is, say, 0.2, that if I could make $1 appear in your profits, it's worth 20 cents in my profits, right? So it gives me like the price of your profits in terms of mine. Very natural interpretation. So how do we actually compute these? What's beta? This is the good one. We know what beta is pretty clearly because large investors have to file what they hold every quarter with the SEC in these Form 13F filings. So beta is just what percent of the firm do you actually control. So mostly observable in data, not too controversial. Far more controversial is this gamma thing, right? It's fundamentally a model of corporate governance, right? How much do I care about each of my investors' portfolios? Okay, so theory gives us very little to go on here, okay? But it does seem like there are a few obvious nice properties that we should have. So for example, gamma should be increasing in beta. The more you own of me, the more I should care about your portfolio. Seems fine. And we think that gamma should go to 0 as beta goes to 0 so you don't have weird discontinuities if I buy one share of your company. So the literature to this point generally kind of waves its hands at this problem and says we're going to assume what's called proportional control. We're going to set gamma equal to beta. Okay, so if you own 5% of me, I care 5% about you. Okay, it has some very nice math, but there's no real foundation to that. It is an assumption. So what we do is we actually don't assume that, we don't impose that. We allow for more flexible forms of gamma being a function of beta. Okay, and so what we do is we test a range basically. So as you can see, we can do square root beta, beta, beta squared. As you go to the right in that list, you're basically overweighting your largest investors, right? If I put gamma equals beta squared, I'm caring just about my biggest investors. If I go to the other end, square root beta, I'm underweighting my largest investors. So this gives us flexibility around what this actual function should be. I just want to point out a few things. So unlike these MHHIs that have been used so far, these kappas that we're studying have a lot of advantages. I didn't have to specify a game. I didn't have to say what a market was. Okay, so these are just very nice primitive objects in the firm's objective function. So we think this is the right way to study this question as opposed to what other papers have been doing so far. All right. I just want to drive home an example of why you should not regress price on MHHI. So what we do in the paper is a really simple simulation exercise where we say, imagine we have linear demand and two firms, and they're just going to set prices according to static Bertrand-Nash. They're going to ignore common ownership and pricing. Okay, so they're not doing any of this common ownership stuff. But we're going to assume that we're sampling from across markets, and there's variance in the A1 term across markets. Okay, that's why we have differences across markets. We have one institutional investor, so we're going to then just compute the HHI, the MHHI from these samples and see what we get. Okay, so here's our little simulation. The figure on the left shows prices across markets as a function of that demand intercept. Okay, so that's the x-axis is the demand intercept, the y-axis is prices. What you see is prices are kind of increasing to the right. We then plot the MHHI delta in the right figure, and it's this parabola shape, right? It's rising and then falling. Now remember, firms are ignoring common ownership entirely. But notice the little green bars that we're going to call that sample 1. If those are the markets you happen to sample and you ran a regression of prices, which are increasing on MHHID, which is increasing, you get a strong significant coefficient. If you instead drew sample 2, the yellow bars, prices are still increasing, but now you'd get a negative coefficient on MHHI delta. So it's really meaningless to do this, right? The market shares are confounding everything here. You don't want to include market shares on your right-hand side. And so again, this is why we think we need to be studying this kappa object, not anything else. Let me go to some main results. So what we do is we actually compute this kappa variable for the universe of S&P 500 firms from 1980 to 2017. And it's going to be pairwise, so we're going to have an awful lot of these kappas. Okay, so we're going to, for every pair of firms, we look at the overlap in the investor portfolios. We think this is useful because the S&P 500 is chosen to be representative of the US economy, right? It's a proprietary list maintained by Standard & Poor's, but they actually do try and make it look like the US economy, so we think this is representative. And again, I'm not making direct claims and outcomes yet. I'll come back to this, but so some of these pairs of firms, right, will be that Delta Airlines has a profit weight on Pfizer, which is kind of silly, okay? So we understand that concern. We'll come back to that. We can show lots of robustness to that. But this is kind of the headline result. What do these kappas look like over time? And I want to focus first on just the red line, just to fix ideas. The different lines are just different models of that gamma parameter. But if you look at the red line, it goes from 0.2 in 1980 to about 0.7 in 2017. So that's, a huge increase, more than tripling of this profit weight that I put on a typical other firm in the S&P 500 over this time period. One thing we really, really like about this picture is notice that for 2017, it sort of doesn't matter which gamma specification you pick, right? I can overweight my big investors or underweight them. It's still going to be about 0.7. It's just because everyone's holding the market portfolio, okay? It's not about who I'm actually putting weight on so much anymore. So this is kind of first main result. Qualitatively, it kind of doesn't matter which gamma you choose. Quantitatively, for 2017, it doesn't matter which gamma you choose. They're all kind of going to be the same answer. Okay, I'm going to just mention quickly, there are a lot of data issues. I'm not going to have time to go through this given the time allotment, but just if you are interested in working with this data, our Brookings paper has a huge data section that summarizes all the problems. I'm just going to skip a few slides and say, what is driving that increase in kappa? Well, we just went and computed similarity measures between investor portfolios and the market portfolio. So we have an L1 measure and an L2 measure, plotted them over time, and it's just because everyone's portfolios start to look more and more like the market portfolio. Okay, so this is kind of the main driver of what's going on. And just to kind of emphasize this point, this started in 1981. It's not like this increase was all of a sudden in 2000 because BlackRock acquired iShares or something. Okay, it was not some kind of a step function. It was a very smooth increase over time. So we wanted to understand how big this could be in terms of effects on, say, prices in markets. So we just calibrated a simple model with 8 symmetric firms, okay, and we have logit demand. If you're not aware of it, there's an excellent paper by Jan de Loker and Jan Eckhout about the rise of markups over time. So what we did is we calibrated the 1980 value to their markup, okay? And we basically just then said, okay, firms, behave as if common ownership is real and kappa is increasing as we see it increasing in the data. And that is basically the blue line. And you see that markups go from about 20% to about 55, or 0.2 to 0.55. Okay? So we also put on the red line, that is the markup increase that DeLocher and Eckhout document in their paper. There has been some debate around that paper about whether it's measured properly, et cetera, but just to give a sense of the magnitudes, it looks like these kappa incentives are big and could actually match the magnitude at the end of that sample. We're not saying these two lines lie on top of each other. Don't get me, please. I want to be clear about that. But we do want to put that up there for kind of comparison. So another thing we did is we looked at profits of these firms relative to competition. So the blue line is if you have these kappas and you're actually behaving according to the common ownership model. And then we added a maverick firm and basically said, okay, let's have one private firm in the market. That firm's not going to play along with the common ownership hypothesis. That firm's going to have a kappa of 0, and every other firm's going to have a kappa of 0 on them. And if you do that, we find it just greatly disciplines this whole effect. Okay, now part of that could be because we did symmetric firms. You can quibble about the details, but it does seem to be the case that if you have foreign firms, if you have private firms, they may act as kind of discipliners in terms of the ability to do this. All right, so as I said, the S&P 500 is big and diverse. What does it mean for an airline to have a profit weight on a drug company or something like that? So in the paper, we actually do this within SIC code and across SIC code. It's actually slightly higher within SIC code, if anything else. We've also explicitly done some callouts. So we did commercial banks, we did airlines, we've done ready-to-eat cereal. So we feel it's pretty robust to different kind of things around the edges like that. What we also do in the paper is we look at what are some of the determinants of these kappas. We find that higher retail share means higher kappa. The reason being retail investors kind of fall out of this whole model, right? Your beta is very small and your kappa is very, very, very small. And so retail investors kind of don't matter, even if they're undiversified. And so firms with high retail share tend to have high kappa. That's generally correlated with market cap, and so similar result there. So the last kind of big thing I want to talk about is the relationship to tunneling. I'm not sure how familiar people are in the room with the literature on tunneling, but the idea arises when you have a divorce between cash flow rights and control rights. Okay, so this is commonly thought to occur in a lot of developing countries where if you have high control rights in one and high cash flow rights in the other, you use the control rights to tunnel profits to the other firm. Okay, and in the US it's considered not supposed to happen, although people have mentioned the word when Tesla bought Solar City or when Elon Musk, the Boring Company, built its tunnel on SpaceX land, right? So you have these kind of weird relationships. What's amazing is in our case, it's actually possible to have a kappa greater than 1. There's nothing about the math that precludes it. What does it mean to have a kappa greater than 1 for another firm? It means you actually do want to kind of tunnel profits to them, right? If kappa gets high enough, you want to just shut down maybe even, right? But in some sense, kappa greater than 1 seems like a risk for tunneling. So the last thing we do in the paper is we just say, well, how often is kappa greater than 1 among S&P 500 firms during this time period? This is one where the choice of gamma does matter a little bit, but let's just pick the red line again, which is the proportional control. And it's something like 10% of our kappas are greater than 1. That's pretty remarkable, okay? And so if you do take this whole model seriously, this is a pretty important implication, okay? So let me wrap up this. So this is the kind of the main paper that we're presenting here. The big takeaways are that this is an interesting model. There's kind of a bit of a hole in the sense of the corporate governance side of how does it all fit together. But the implications are huge, and it's not a crazy assumption to just think that firms are maximizing shareholder portfolio value. And once you do that, you get these incentive terms, these kappa weights that you can plot, and we do that, and we find that they've been increasing dramatically over time. And it's not because of any one particular investor or anything like that. It's just because of everyone's buying the market like we've been told to do. In terms of magnitudes, from 0.2 to 0.7 is very big, right? One nice feature, a maverick could discipline pricing. And then, as I just mentioned, there's some red flags around this tunneling issue. I'm out of time. I won't be able to talk about the serial paper, but if you're interested, again, we are investigating how to actually test this in a differentiated product setting. It's progressing slowly as structural I/O work tends to. The initial evidence that we're finding, we have kind of some more basic models. We're kind of adding more layers of complexity. But so far, we're finding support for the standard competitive model among ready-to-eat cereal products. Very preliminary. we look for a working paper in another few months. Thank you very much.